Here's a puzzle, just for fun. I'll give you 5 seconds to pause the video so you can work on it before showing you how I solved it. We're asked to find the ratio of this shaded area, I'll call it A sub q, the area of the quadrilateral, to the area of the whole rectangle. The rectangle's area is just its length, AB, times its width, BC. But finding the quadrilateral's area takes some more work. So let's first notice that it equals the area of the whole rectangle minus the area of 4 triangles. I'll call them triangles T1, T2, T3, and T4. And we'll indicate them here. Before we can work out the area of each of these triangles, we need to sort out some dimensions inside the rectangle. So let's notice first that this red line has a length of 1/2 AB, and then because M2 is a midpoint, this orange line must have a length half of that, 1/4 AB. This yellow line, then extending the rest of the way to the right across the rectangle, has a length of the remaining 3/4 AB. M3 is a midpoint, so this red line must be half of the yellow line, that's 3/8 AB. And now this red line we can see is 1/2 of BC, which means that this orange line, because M3 is a midpoint, is half of that, 1/4 BC. This vertical yellow line then takes the remaining 3/4 BC, and coming to the midpoint M4 shows us that this red line is half of that, 3/8 BC. Now we can work out all of the triangle areas. Triangle 1 has an area of 1/2 of its base, BC, times its height, and that's the length of this red line, half AB. So we see that triangle 1 has an area equal to 1/4 the area of the whole rectangle. Triangle 2 has an area of 1/2 of its base, this distance AB, times its height, shown in red here, that's half BC. And we see again that this triangle has an area 1/4 of the whole rectangle's area. For triangle 3, we have an area of 1/2 its base, the length BC, times its height, again shown in red, that's 3/8 AB. And that works out to 3/16, the area of the whole rectangle. And finally we have triangle 4, with an area of 1/2 its base, half of AB, times its height, shown in red, 3/8 BC. So that works out to 3/32, the area of the whole rectangle. If we substitute those results into this expression for the quadrilateral's area, we find after simplifying that the quadrilateral's area is 7/32 the rectangle's area. So bringing this back up to our first line, we see then that the ratio of the quadrilateral's area to the rectangle's area is 7/32, which is about 22%. And that's the answer to the puzzle.